Hey guys, I'm Suyash, and today we are going to talk about ideating security checkpoints in rapid engineering. I have my colleague Rahul here to present the webinar. Now, just to set the context, rapid engineering brings increased demands on security. We see the applications being built and deployed in the matter of weeks, and in some cases in the matter of days. Usually, the security checks is not cut out to match the pace of the development. Now, to bridge this gap, security as a function needs to grow to address these different areas and do it with increased velocity. In this webinar, we basically focus on translating a plan to keep the software secure in a DevOps environment. Also, it can be readily adopted by engineering teams. With all that said, I hand it over to Rahul. You can take it from here, Rahul.
Thanks, Yash. Good morning or good evening to everybody, depending on which part of the world you're joining in from, and welcome to our webinar, which is the next in series of the webinars that we do on a monthly basis in keeping in scope for application security and DevSecOps and things like that. So in today's webinar, before we get started, a little bit of brief about myself. My name is Rahul, and I'm one of the co-founders at we45. I used to be a security engineer by study and in terms of my first area of work, and then slowly moved into the security and techno marketing side of things. Some of the focus areas that as a company that we work on, and in terms of a personal core domain as well, have been listed here. So if anybody has any questions or you have any further clarifications on any of these topics, would be happy to kind of chat, have a separate discussion. Having said that, let's get into our webinar for the day. So in today's webinar, we're going to be touching about a couple of topics. We're going to be talking about what is known as the Software Security Initiative, or the SSI. We're also going to be talking about typical rapid engineering checkpoints that one would like to have as part of their product engineering pipeline for us to have a seamless and a high secure throughput of product. And we will be talking about specific stages of the product development and trying to map that with what kind of security checkpoints should ideally be there. Now, one of the things that I usually would like to say as a disclaimer to this particular topic is, when we say checkpoints, the first thing that comes to our mind, especially for people from the engineering side of things, is to really look at checkpoints as a certain bottleneck or something that really goes against the inertia of product engineering that has been kind of happening at a certain set frequency. But one of the things that we need to really realize, and probably even have as a core thread across the webinar, is we've tried our best to ensure that when we talk about checkpoints, we don't talk about it as boom barriers, but we actually talk about it more in terms of turnstiles, and by which you don't necessarily have to deviate or try and put a lot of bottlenecks or roadblocks in terms of what engineering teams and security teams are already used to today in terms of their product engineering process. So having said that, if you just have a look at today's product engineering processes or technology, it's kind of moved a lot from the last, I wouldn't even say a decade, but even if you look at it from the last 2 to 3 years or the last 5 years, you've seen a significant change in the way that product engineering has kind of evolved. Not only do we see a variation or a huge change in terms of the technology stacks that have been adopted for product engineering, where we're looking at more microservices, we're looking at more contemporary tech stacks like Golang and Python and things like that. But we're also seeing a shift in terms of the product engineering process by itself. While some may argue that the Agile is not truly Agile and it's still somewhere between waterfall and Agile, or something like what people might call an Agile fall. But the truth really is that the whole digital process and the people of going more digitalization processes have really led to organizations not being able to stick on to releases that have been far and few in a year, and you actually see more releases that keep coming on in terms of an annual or even a quarterly engagement, quarterly release cycle. And all of these have obviously would have their relevant touch points with respect to security, with respect to infrastructure, with respect to SaaS teams or DevOps. So today what we're going to look at is really the security angle of things and try and see in terms of what changes have been done in terms of the security process, and what more changes would be a good to have for us to keep in line with the throughput that we talked about a little earlier. However, when you look at the application security side of things, things are slightly murky. So when I say that, though the last 2 to 3 years has been a stage where there have been a lot of people talking about security assessments, talking about shifting left, and thanks to a lot of marketing efforts from various organizations, there's a higher level of awareness in terms of having security as part of the SDLC, as so to speak. But having said that, you still see a lot of, at least with our customers, when you talk to them, you would probably see at least 6 out of 10 customers still sticking on to a security process that is either once a year or twice a year, which is really end of the chain. And they have trouble either moving left due to bandwidth constraints, due to financial constraints in terms of being able to adopt to tools or technologies, or a combination of both, or probably even in terms of a skill shortage. So you still see a lot of folks adhering to security assessments in some form or shape being done only once or twice a year. It might still be more than what they've been traditionally used to, but it's still far away from what the ideal stage of being able to embark on the whole security journey is. Now, threat modeling, again, has been one of those things that has been spoken about a lot, but there's so much of variation in terms of what the definition of threat modeling even is. You have people looking at threat modeling as something that's purely a blueprint activity, even before you write your first line of code. Or then you have people looking at threat modeling as something extremely granular, which almost makes it a bottleneck for people to even start off on the first step. So we'll talk a little bit about what that midway of threat modeling really is. And then you also have the problem of containing security issues that are once propped up, and then you keep seeing that coming up in multiple releases. And especially if you have a person-dependent security initiative, obviously what's going to happen is you have a pen tester that's probably found the security issue in month 1, and in month 24 or in month 20, you have that security issue propping up again, but then now you realize that that person is no longer there, and who's going to reproduce the issue, what happened to the issues, and things like that. So you're going to see a lot of these issues, and we've been seeing these issues for the last couple of years as well. So we will talk about that. And finally, we will also see in terms of what best we can do to try and have some kind of quantifiable metric that would really measure the state of software security as we know it. And this is one of those things that we've kind of said and shown. This particular image has been there in our presentations for the last 3 or 4 years, and it still holds true even as we speak today, because the state of the speed of application security is still far behind the delivery of products as we see on a year-on-year basis. So let's see what a software security initiative or an SSI is. So one of the things that when we usually talk about something like this, and we say, you know what, you guys need to have a software security initiative, and especially if that's Greek and Latin for a few, the first thing that they're thinking about is, do I need to do more work than what I'm doing today? So does that mean that there's going to be a huge deviation in terms of the effort that I'm putting in, either in terms of a security roadmap or in terms of an engineering roadmap? So is that going to be the case when you talk about a software security initiative? Fortunately, that's not really a case, because when you really look at what the formal / a casual definition of a software security initiative, it is really a set of activities that help you measure and maintain the state of software security. And that, having said that, that really, in essence, what that really means is security and engineering should largely be able to continue what they're doing today as part of their individual processes. And we've said that earlier as well, application security is not a one-size-fits-all. So you're going to have even 2 organizations really who are in a similar domain, who are kind of working on products that are in competing spaces, but they are going to have processes that are different. They are going to have team compositions that are different. So therefore, the AppSec controls for team A is going to be very largely different than AppSec controls for team B. So it's really about what works for you best. So what we're trying to achieve by a software security initiative is really have an umbrella of sorts over and above your existing software delivery models that kind of, to the best of the ability, seamlessly integrate certain turnstile controls that we talked about earlier, that kind of ensure that when you move to stage A, stage B from stage A, it's almost really looking back slightly as though you're looking at your as a blind spot view to just see that, have I done what I need to do from that particular stage level to ensure ensure that I move on to the next stage. So we will see more in terms of what an SSI is, because what the webinar is really going to talk about in the next couple of minutes is really breaking down this SSI into smaller segments that kind of map to the various stages of the SDLC. So the objectives of an SSI is fairly simple, right? So the first thing is to really drive the concept of security in terms of a shared ownership across various teams. When we talk about the AWS security model, we talk about a shared responsibility model, and this is something very similar when we say there needs to be a shared ownership or a shared responsibility across various teams as well. Now, you would have heard a lot of people say this, and some of those people, and you're right when you assume that all of this is easier said than done, but then what we're really looking at is most of these things involve a huge amount of cultural angle to it. So there was a recent conference that I was attending in which there was a particular talk that talked about the differences in terms of security practices between the East and the West of US. So what essentially the talk was really about was, do we see a change in terms of what people mean by software security in the typical Bay Area Valley customers versus the sense of software security from an enterprise customer? And interestingly enough, there was a varied level of differentiations that was drawn out, and most of those differentiating factors came about to really a cultural element of being able to imbibe security in that process. So we're going to be able to see how an SSI, just like any other compliance regulation, could be one of those things that really help drive security from a top-down approach for executive and C-level managerial folks to be able to really set that baseline to say, this is my SDLC process and this is my secure SDLC process. So think of an SSI as something like that. And we're essentially going to be able to also hopefully derive or be able to transform security from moving to a revenue center, not just from a cost center, because today already there have been a lot of product companies whose sales teams are using security as one of their war cards to really talk about a differentiating model, because they know for a fact that their customers are equally well informed in terms of what security practices need to be in place. So sales teams today go ahead and actually have that as part of their sales collaterals, where 1 or 2 slides is focused in terms of, here are my security and governance mandates internally that we follow to ensure that one of those pillars of customer satisfaction is also security. So most of these things can be accomplished by having a really, really good SSI in place. So there are, just so that we kind of bring about a certain familiarity to an SSI, one of the 2 popular schools of thought in terms of SSI is the BSIMM and the OpenSAMM. Of course, the BSIMM has come up with its latest version a couple of weeks back. The slide has not updated, but then if you actually see the slides, you would see that, and this is something that we recently showcased at the ISACA presentation as well, where we said that, you really see these 2 schools of thought that help you define what an SSI really is. So you have 4 domains, you have which is similar in both OpenSAMM, which is an OWASP project for those who are interested, and BSIMM is something that came about with Digital and Synopsys as well. So you have these various activities and clauses that are defined in both of these frameworks, and then you essentially start drilling down across these frameworks to really score yourself in terms of where you stand as far as the software security initiative is concerned. So people who are interested to kind of look this up, please feel free to, it's freely available. The documentations are available for anybody to kind of just have a look into and see what these are about. So let's talk DevSecOps, because that's something that even if you're talking to a 5-membered company, which is typically just starting off to kind of build an MVP version of their product, or if you're talking to a large financial institutions, the people have been talking about this for a long time now. True that people call this DevSecOps, some of them call it rugged DevOps, SecDevOps, so irrespective of what you might call them, this is a common line of discussion that's kind of that has been catching up with most product engineering teams. And really with that advent, one of the things that we're seeing is they're really talking about acceleration of existing security practices. And one of the important things that one of the salient features, I wouldn't say important, out of the many things that DevSecOps talks about, is that whole integration between dev, security, and QA. Now, that's a very interesting bit, because one of the things that we've seen is that QA has for long always been one of those gatekeepers in terms of ensuring that the truly the most stable and the most rightfully working version of the product goes out to the customer. So they already have the keys to the kingdom as far as letting a product out is concerned. So DevSecOps really enables a lot of QA teams to ensure that security is part of that mixture, for them to be able to, with little to no deviation, be able to kind of help them also measure security as one of those criteria. And then you also have what is called as a continuous feedback resulting from various production and pre-production security tools, and being able to put them back into the design philosophy or go upstream in terms of design and development, for them to be able to take feedback from the various kind of vulnerabilities or threat patterns that teams might see coming in later in from the product lifecycle. And one of the other things that finally DevSecOps has forced in terms of a change is everybody needs to get code. There was a point in time where security folks were getting by doing about what they were doing without really needing to understand code. But then the whole process of that congregation of security, QA, DevOps, SaaS, and Dev coming together is the fact that everybody needs to get code. So the whole job responsibility of a security engineer today has really transformed from just being able to assess security vulnerabilities, either using or not using tools, to a state where you're saying people need to understand code and security guys need to understand code for them to be able to codify security as well, thereby helping them kind of scale their existing security practices to the next level, or B, understand code so that they would be able to really go and have a deep dive into the actual code base of the product as well. Sure, you might have SAST products that could go ahead and do your source code scans, but then it's those very intermittent code walkthrough or tabletop code walkthroughs that software teams and the security teams have, which essentially sometimes could even be over a brown bag session, that really help you understand how the developer mentality of writing that particular module of code is, and then the security guy is coming in and trying to come up with, let's say, exploratory test cases, for example, for them to be able to have that bit of module explained better or tested better. So these are some of the things that DevSecOps really bring onto the table. Now, this is the Gartner's infinite loop of DevSecOps. This has been there for the last couple of years. And one of the things that we wanted to do is to try and uncomplicate this diagram in terms of the various moving pieces. So what we've done is the we45 DevSecOps model really is to go back to the drawing board in terms of understanding what the key elements of an SDLC is. So essentially you have the plan, code, build, test, release, deploy, and operate and monitor phases of the SDLC. And then parallelly, even if it is a parallel activity, the security guys would essentially have a threat modeling phase. They would have a SAST or a source composition analysis phase. Then you would get into the DAST and IAST. And then you would, for more mature organizations who are actually looking at continuous development and continuous deployment, would probably have infrastructure as code also as part of the pipeline. Then finally, you would have the security monitoring and attack detection phase. Now, true DevSecOps in our experience has been that meshing the security phases right into the development phases. So when you say that, so if you just had to reorganize this entire model, you would essentially see all of these go away, and then you would see that the actual DevSecOps model is in really going ahead and seeing what security phases can be put forth into the development phase. So if you see today, threat modeling as an activity is something that covers most of the planned or the design phase of product engineering, and probably getting into slightly into the code as well. And then you would see that the SAST is really something that largely covers across the build and some bit of the test model. And then the DAST and IaaS testing is largely the testing phase, which goes into slightly into the release phase of the application as well, depending upon the tools that you use, the processes that you have. And then you have the other phases kind of taking their rightful positions in terms of the SDLC. So conceptually, one of the things that the Software Security Initiative also focuses on is for us to be able to take these security principles and really plug them into their relevant places of SDLC. In simple speak, what we're essentially saying is, let's look at 4 phases of the SDLC. Let's call them plan, code, build, test, release, and deploy, operate, monitor. And then you have these 4 distinct phases in which we will actually break down the SSI into. So let's get into the actual SSI and see what these security checkpoints really look at. Like I said, these are not really boom barrier type points. These are more in terms of turnstiles. And again, this is not a very restrictive or a very highly prescriptive model of SSI implementations, but this is just something that we've put together as a skeletal structure. So feel free to kind of build your own recipe of an SSI that works well for you guys. But what we are looking at right now is really a stepping stone of sorts that would probably help you kind of take this to further refinement. So the first stage is obviously the software design phase. Here's where you're essentially looking at product architects coming in and trying to build that model, software model from the ground level. You're talking diagrams, you're talking UML diagrams, you're talking sequence diagrams, or whatever it is, right? So let's look at some of the things that would ideally be applicable in the software design phase. So threat modeling is something that comes to, like I said, is something that's been talked about, something that's been practiced as well, but then we're just trying to demystify some of those concepts within threat modeling as well. So one of the things that we've seen is threat modeling usually becomes kind of a bottleneck for people to adopt as part of a full-fledged SDLC. And lastly, the reason for that largely is either them being too granular. So one of the things that we would like to do is try and break down threat modeling as something that a QA or at even a unit testing level, right? Forget about QA. You could even look about threat modeling as something that a developer could use as part of his or her unit testing level. So one of the things that we've done is as part of our threat playbook framework, we have actually broken down threat modeling into a threat model and then a test case model as well. So let me explain what that essentially means. So here is a threat modeling diagram. So one of the basics of a threat model is you have user stories that would essentially talk about a certain functionality, and then for every user story, you would have something called as an abuser story. So this is something that developers understand quite easily because they are already used to the terminologies and they're used to the processes of user stories. So if you could talk about abuser stories for user stories, and that's the first kind of opportunity to bridge the gap between development and security folks, because you're taking a particular module and you're essentially breaking down the module in terms of what that is supposed to do and what could potentially happen to that module. And you're not even getting in terms of code, you're not talking modeling, you're just talking simple speak English at this point in time. So you're essentially saying, let's talk about a user story and see what potentially abuser stories could come up from that user story. Like we said, what can be done to abuse the functionality. And then from that, you derive what is called as an attack model, which essentially is how do you make your abuser stories come to life, which is slightly getting into more in terms of the various permutations that could potentially go wrong, and then how would you essentially go ahead and weaponize it. And once you've done that, you essentially start writing in your test scenarios. And these are your, typically, if you look at it from a pen testing perspective, these would be your actual test cases that you would write for a particular attack model. So what you've effectively done right now is you've taken a user story and then you've broken that down into multiple abuser stories, and those abuser stories in turn break down into more than one test scenario. So you really have a 1:n kind of relationship between a user story and the number of test scenarios that you could come up to. And a byproduct of this is that you also have a well-documented set of test case scenarios, which actually moves from being just person dependent to a process dependent activity. Because in this age, you're talking about security skills being far and rare. A lot of people are having issues with hiring security folks, so therefore they're looking at ways and means in which they can normalize and standardize security testing. So this is the first level, and you can probably start standardizing it to say, okay, what was the various test cases that I have had for the previous iteration of my security assessment? So threat modeling, from that perspective, if you look at threat modeling as an abuser case design principle, then this is a great way for you to actually go ahead and write some of those abuser cases. So here is an example of what we would call a user story or test scenario mapping. So essentially, I'm looking at a simple use case where we have a user story. Like, as a user, I would want to search for something using the search functionality. This is completely agnostic of what the product is. Just let's imagine a search functionality. So two potential abuser stories that could come from a security perspective is I could either go ahead and search for notes of another user and therefore have a breach of confidentiality there, or I could actually have some kind of a malicious script included as part of the search functionality, through which I could actually have them redirect to another website, or probably have some kind of a malware inflicted upon them. Now, let's just follow the yellow boxes, because those are the ones that we are going to essentially break. So we have two abuser stories. So out of this, I'm just taking the first abuser story, right, which is essentially I want to be able, as a bad guy, I might be wanting to search the notes of somebody else. Now that particular abuser story could essentially, break down into two attack models. Now the first attack model in which I might be able to achieve this abuser story is by performing a man-in-the-middle attack. The second way in which I might probably weaponize this abuser story is by performing injection attacks again. So two very simple examples, right? So one user story has two abuser stories. One of those abuser stories again breaks down into two attack models. And let's take one of those attack models, which essentially is attackers can perform a man-in-the-middle attack. Now, the man-in-the-middle attack can essentially break down into 4 test scenarios, right? Which actually means that I would first need to check if the application is on HTTPS, then I'll check for the strength, and then I'll check for the header, and then things like that. So let's take away the actual test scenarios, or you could have more than this, or you could have less than this, depending upon what the application is. But the point really here is, from just one user story, today you see that part of the user story just gives you 4 test scenarios by just breaking that down in terms of a user story. So just look at this breaking down into various user stories, so you have a comprehensive understanding of what the entire attack vector or the threat surface of that particular application is. Now, this is something that is the first step in terms of achieving that bridging the gap between security and dev. And one of the ways in which this can be really leveraged is most of the users today use Jira or Confluence to kind of map some of their user stories. So you can achieve this very simply by having a small add-on on your Confluence portals, by having one mandatory field along with the abuser story to say, when every time you write an abuser story, it will not allow you to move to the next step without writing a corresponding when you write a user story, it won't allow you to move without writing a corresponding abuser story. A small thing like that could really help you capture some of these things at a fundamental level itself. So I think there are some questions. I think the team is noting that down, and we will get to that at the end of the session. So if you really look at security in design, you're looking at these major activities that's done, right? So essentially you need to consolidate your security requirements, and this what I mean by this is, depending upon your product, you might have various compliance mandates or particular regulatory requirements that you would need to achieve to manage that. So the first step is really understanding what those are. So that needs to be essentially that needs to be passed on to various groups, so that every group in product engineering and security really understands where that product stands in terms of its regulatory obligations that it comes under. And then you would have design reviews, you would perform threat modelings. And one of the other interesting things that makes sense to be done in this stage is to really get one of those third-party feeds, right? So it's always good for you to have to know what the existing landscape of threat looks like, because the moment you have your tech stack jotted in, the moment you have your architecture framed up, using just the tech stack of choice, you could go ahead and get a lot of feeds in terms of how does my tech stack map into existing set of issues that have already been found or exploited and things like that. So if you take really legacy platforms or platforms that do not necessarily have a lot of inbuilt security controls, you will see that you will have a lot of open security issues even today. So you can really go ahead and assess that first level understanding of how technology stacks really affect the threat or the attack vector of the application. And then you would probably go ahead and based on that, you would go ahead and bring together a tool set which says, okay, here's my tech stack, here's my architecture, what kind of tools do I need? Which is a parallel conversation that security might have while this discussion about design and architecture is happening. So then once you, as part of your scrum of scrums or your intermittent meetings, security would come in and say, okay, based on the last design meeting that we had, here are the things that we've been able to kind of consolidate, and let's discuss this across the table. This would also help you prioritize training needs. So you could essentially say, okay, this is what I'm developing, and based on this, these are the various kind of moving parts that we see. What are my skill requirements in this? Do we have existing skills that touch upon these factors, or do we need to kind of have more training needs being planned for? So the entire planning of the security assessment or the security aspect of the product engineering kind of really stems from here. So at the design level, the first design checkpoint that we think is very important is to really have that user stories linked to Jira story, linked to user stories as part of your documentation portal of choice. So this is probably the first checkpoint that is very, very fundamental as part of your design. After design, let's move on to develop and deploy, which is the phase in which you actually go ahead and write code. So in that, I think this is something that we're seeing is has become the norm of sorts today in most organizations, except that when people talk about development security in the dev stage, the only thing that you're thinking about is SAST, which is all right, because a lot of commercial SAST today do give you the ability to kind of not just do SAST runs as part of the code base, they also give you an interface in which SAST platforms can actually link up to the developer consoles or the IDEs, thereby giving them the opportunity to run SAST scans as part of their code itself. So some of them even give you an option to run it on an interpreter kind of a mode where as you type the code, you have the security checks being done. So it's almost like a spell check kind of a scenario where you could just go ahead and correct what you do as you write code. And then you also have places or organizations that have a SPOC model or a hub and spoke model, where each of these security teams has one person who's responsible to liaise with the central security engineering team. So as and when the code is being developed, or as and when the code is being transformed from a design to a more prototype or an actual version of the application, the security SPOC really is the one who who brings in certain best practices into that smaller pod of team, either in terms of coding guidelines, or either in terms of doing some quick reviews in terms of your the code, or even something like looking at the results from the SAST and then trying to analyze and triage those results at that particular time itself. So that is something that happens at that code level, or that's a good way for us to have that kind of a checkpoint in the development stage. So as a development checkpoint, it makes sense for us to not just run the SAS or SEA scans on the code base as a whole, but it will be great for us to have a commercial tool or an open source tool. The reason I say commercial is there aren't many open source tools that give you that direct IDE level integration for you to be able to assess and mitigate codes from that perspective. But having said that, if you have any SaaS tool of choice, try and see if you can kind of do that more upstream in terms of an IDE level check, rather than just having running checks once the code has been pushed into the mainstream. This is a place which would be a good place for us to talk about the AppSec toolchain. Again, I'm not going to spend a lot of time on this because this is something that has been talked about by various other not just vendors, but in terms of practitioners across various conferences. But one of the things that I would point out here is it's not really about the kind of tools that you have in the tool chain, but what's more critical is in terms of the fact that in terms of how you arrange them or what kind of frequencies you would run them on, because we've seen a lot of cases in which people have the best-in-class tools, but then they've not really factored in terms of how much time it takes for a DAST tool to run, for example, which could take a couple of hours, days, or in some cases even 1 week for it to run a full-fledged scan. So it's very, very important for security teams and DevOps teams to really understand that they don't necessarily arrange tools as furniture, just because they're not going to be able to give you the same kind of result that you kind of envisage. So it's very important for us to have that kind of a right mix of tools that work for you and are being triggered at the right point in time. I also am a big fan of what is called as the force multiplier effort, because one of the things, and we're a big proponent of open source tooling and things like that. So if you have one or more commercial tools, try and see if you can plug them with some of these equivalent open source tools as well, because that will do one of two things. The first thing that it will do, it will try and give you that additional signatures or the additional kind of checks that the commercial tools might not. Worst case, you might have two tools performing the same thing, but best case, you will actually have additional issues that the commercial tool might not point out, but the open source tool might actually point out. The second thing that it will also do is at the end of a year, you'll be able to assess in terms of how well your commercial tools are actually performing. Because if your commercial tool is only going to give you 1 or 2 results more than the open source variant, you can actually might as well ditch the commercial variant and just use the open source tool and save a lot of money as well. So it's good for you to probably have that kind of mix. But having said that, fair warning, especially if you're talking large-scale enterprise systems, you might not necessarily have the bandwidth or the time for you to really run multiple tools at the same time. But if you're a smaller shop, or if you're a smaller product company, or if you're just trying to embark on the journey of DevSecOps today, it might make sense for you to kind of have that level of mix and match of tools. The other thing is being able to perform what is called as a parameterized scan instead of a simple scan. Now, one of the things that parameterized scan does is, especially in terms of contemporary tech stacks, which are largely APIs, you will see that a lot of standard scanners don't work. For example, even if you're a shop that's running, let's say, a Zap or a Burp, you will see that unlike a URL-based application where these tools can actually go ahead and spider the application and then find out variables or spaces for them to fuzz parameters, an API really restricts you to do that. So one of the things that you might want to do is probably make the tool work alongside a walkthrough script of sorts. And most of the QA teams today have already written automation scripts for them to be able to walk through the applications and point specific parameters on specific name fields or specific field values. So you could actually leverage some of that and use that in conjunction with these parameterized, with these DAST tools for you to be able to get more coverage. It will also help you to focus the assessment on certain parts of the application rather than running the tool on the entire application. So instead of you running Zap or Burp on the entire app for the iteration 1, and again running the entire thing for iteration 2, you can actually focus your DAST scans to be able to run only on certain section, especially the new section of the code. Thereby, you'll be able to save a lot of time in terms of the DAST variations as well. So if you have more information, if you need more information of how to do this, feel free to kind of check out some of our blogs that we have on the we45 portal. You will see a lot of interesting ways and how-to blogs to say how do you actually run Zap along with the QA script, or how you run Burp along with the QA script, how do you plug it into the CI pipeline. There's a lot of interesting information that's available for you to take advantage of. And finally, this is an example of a toolchain architecture. This is something that's, again, this is just a very skeletal structure. Various people might have various versions of this, but this is just a simple way in which you could probably have a CI talk to a set of SAST platforms. And then once the SAST scan is done, it will be deployed, and then the DAST scans essentially kick in. And the central to such an example is really what is called an AVC or a correlation device that would essentially ensure that duplicate scan results are correlated, and then you only find, you eliminate unnecessary noise from the system, and thereby helping engineers and security teams to really work on vulnerabilities that matter the most. Let me just see how we're doing on time. Okay, so we're okay. I probably have another 10 minutes or so before we break for questions. So we'll just try and see how we could do this this time. Okay, so security regression is something that I want to spend a little time on because it's a concept that has recently come to the forefront. And this really is that going back to the QA mapping that I talked about earlier. So one of the things that we've always seen, and this is something that most of you might agree, is that QA as a function has predominantly been a function that focuses on non-security parameters as far as the release scenario is concerned. They usually focus on functionality, they focus on performance, they focus on all other bunch of stuff, but then security is something that's always not given to them. Part of the reason for that is because security is looked at as a very tool-driven process, which is still true depending on the kind of apps that you run, but more importantly, it's the kind of skills that requires for application security, which the QA teams might not have. But then what if there was a way for you to find a certain fabric that helps QA teams also jump onto the application security bandwagon, thereby being able to share that bandwidth to a certain extent. Now, one of the things one of the ways in which that can be done is the walkthrough scripts that I talked to you about earlier, where you can reuse some of the bit of QA automation that QA has and use it from a DAST perspective. But the other thing is very interesting is what we call as the exploit scripting. Now, one of the things that exploit scripting is assume that there is a particular security issue that an application security engineer has found, and then they've been able to exploit that particular vulnerability, which essentially, let's say, is a business logic flaw. It is not a flaw that a tool has identified, in which case it's easier for you to replicate it because you just have to run the tool again, and provided that that issue is fixed, the tool will find it again. However, the tool won't find it again. However, what if it is a business logic flaw? In most cases, business logic flaws are something that an application that an engineer finds it manually, and then trying to see whether that particular vulnerability has resurfaced becomes a real bit of an issue, especially if that engineer is not in the organization, or even if sometimes they really forget in terms of how they went about weaponizing that, or how they went about unearthing that. So in such cases, what might be useful is to try and automate that exploit script. So one of the things that we do at we45 as part of our assessments is every time we perform an assessment, along with the assessment report to our customer, we also give them a bunch of exploit scripts. And this exploit script is something very similar that the development has used and the QA has used. So it's like a Selenium script that would run reenacting the sequence of steps that the security engineer performed, thereby being able to follow the exact steps and reproduce the issue for the security engineer to act up, for the development team member to act upon. So if you create such scripts and give it back to the development team, it does one of two things. First thing is that it reduces the back and forth between development and security teams to say, okay, I was able to find this issue, but you are not able to reproduce it. So how do we fix this? So that issue does not exist because you're giving them the Selenium script. They can just play that Selenium script and see how they were able to reproduce it, and perhaps even better fix it. The other thing that the Selenium script really does is in terms of a regression scenario. So QA usually has a lot of regression scripts that would ensure that functional bugs that once surfaced does not resurface again. So they could just run the regression script and ensure that, okay, no previous bugs found resurface. In a very similar manner, you could do that from a security perspective as well. In combination with the AppSec tool chain that we used earlier, where tools will ensure that tool-based vulnerabilities do not resurface, you can plug in the security regression scripts as well, so that you could ensure that in addition to the tool vulnerabilities, you also have business logic flaws that do not resurface. So this will be a great way for us to ensure that at some level, I'm not saying this is going to be very comprehensive and every single bug would be identified, but you can at least start somewhere to say that you are eliminating some bit of redundant activity from being performed at every stage of the assessment. So we have a small diagram for this. So this would be a typical security regression architecture. So then you have your first target application. You could just follow the numbers on the screen in terms of the steps. You have a target application. It would first be, the first time around, you would do only a manual pen test, and then you would record those scripts of the manual pen test and keep it with you. The second time that application comes in terms of a second version, it would essentially be subjected to the QA scripts first. And then after the QA script, it will go to the application toolchain that we talked about. parallelly, the new version, the new section of the application could be again be manually tested, and then that, if you find any exploits in that manual test, that would essentially be recorded, and then you have it as part of your test repository. So imagine this being done for every iteration. What you would eventually have at the end of a year is that you'll have a set of issues that you found over the period of last 12 months that you found, it's recorded and it's there with you. So when you run the 15th or the 16th iteration of regression, you will see that subsequent versions of the application, the security engineer spends lesser effort on testing the application as a whole, and then most of it is being offloaded to either the AppSec toolchain or the regression scripts from that perspective. So a great way to reutilize the time that the security engineer spends on running successive redundant scripts. So coming to the deploy and test, we've talked about all of these checks, all of these things in our earlier two slides. And the main checkpoint here is to be able to take advantage of the existing gates that QA has created in terms of a go or a no-go of an application being able to being ready for it to be published to the open world. So you should, if you're able to kind of piggyback on some of those security gates that QA or functional gates that QA have and be able to map functionality security there, that would be a great way for us to kind of achieve that whole balance of QA and security. So that's really the interesting or the most important gate as far as the deploy and test is concerned. And finally, we come to the product release and monitoring. And one of the things that we've seen is that since so much has been said about shift left and just moving upstream, sometimes you just forget to kind of fall back to the shift right philosophy as well. And by shift right, what I mean is that you either need to ensure that your production systems are protected well enough, or at least it should be configured in a way that you fail safe. So one of the things that's very important is while you select your tool chain just from a development or a pre-prod environment, it's also important for us to have systems in place in production that would help you kind of give that whole feedback system that we kind of talked about in our earlier slides. So as much as you might test things in development, as much as you might have these tool chains as part of pre-prod or UAT or QA, you still are not, nobody would be able to give you an assertion to say that there could nothing could go wrong, because especially in terms of applications, you have that added feature or the added layer of environment, environmental variables, the kind of infrastructure components that are there, which is a whole different ball game altogether. So if you were to look at purely from an application perspective, you would have probably sealed some of those gaps. But just so that we are also sealed off from the production side of things, you would really need to have a lot of production-based tooling and production-based processes as well. Some of them are your WAFs and your RASTs. RASTs are a great way to kind of keep in check the application while it's being used, because they kind of simulate an agent-based mechanism for you to be able to say that, okay, as the application is being used, it actively checks for security issues at the production level. And what's interesting is if the RASTs or the IAST tooling give you some trigger points or some alerts mechanisms, it's really important for us to take them back and put it as part of the initial design principles of the initial stages of the engineering process, to say, I have visualized the following threat scenarios from a proactive perspective, but then I also want to ensure that my test cases contain these additional checks that I have got as a result of the alerts that the RASP or the WAF generated. So that what you're doing consistently is that not only is your test cases or your testing mechanisms in place just proactive based on what you think might happen, it also actively includes test cases based on what has actually happened or what kind of alerts that are actually being seen in production. So you have this very good integration of checks that are just based on presumptions, and then checks that are actually based on facts and statistics that you get from the production tool chain as well. And a lot of companies, especially the larger companies, also resort to a lot of bug bounties, which essentially means is that you invite a lot of folks from the outside to have a go at your application, and then it's really an open field for them to really go ahead and find security issues, and then you get a different perspective, right? So you essentially have them look at an application like they've never looked internally before, and then you have those vulnerabilities as well. But irrespective of that, the the whole idea here is for us to establish that feedback loop, for us to have that whole continuous improvement in place. With that, the last slide that I have is really a consolidation. I know that this webinar is largely based on content, so one of the things that you will see is that there's a lot more for you to observe on the slides, which you will have access to as part of the recording. But one of the things that is very important here is that these are the various things that this is a one-slider that kind of really summarizes the various checkpoints or the kind of turn spells that you would have at each phase of your rapid engineering process. So the differentiation between the colors here is that the ones that are in gray or black are the ones that you would implement the first time the product comes into the rapid engineering kind of pipeline. So the second time the same product comes in, the reds would essentially start kicking in. So the black points are the ones that we just saw. The ones in red are the ones that you would essentially additionally do from the second iteration onwards. It is just an extension of the points that we've seen earlier on, but then it's just one of those summary slides for you to have a single slide of saying, here is where I can probably get started off from. I know we're just exactly 10 minutes out, so this is pretty much what I had as part of the webinar today, so I will take any questions that the team might have.
Thank you, Rahul. We can start with the Q&A now.
Okay. So
the first question here is, which threat modeling methodology do you recommend for DevSecOps culture?
Okay, so this is a very common question that we get, and unfortunately, I wish we had a specific answer, but I have to give you a generic answer here because it really depends on what is comfortable to you. Now, if you asked what do we use at we45, we use Stride most of the times, right? So because Stride works for us well, because we do a lot of threat modeling from a attack-driven threat modeling. So our threat modeling is largely attack-driven. It's not really defense-driven. So when you're looking at attack-driven threat models, Stride works well for us because it's already categorized the attack model into spoofing, tampering, repudiation, disclosure, and things like that, right? So all that we need to do is try and ensure that our threat models fall into one of those buckets. However, there are teams that decide to use something else. They might use a NIST, for example, or they might use something else that works well for them. But the idea really here is not to get bogged down with the actual methodology, but and that's what we said earlier. The idea here is to not change what you're currently doing. So if I were to tell you this threat modeling methodology is wrong, then that would essentially go against the whole principle of a software security initiative. Software security initiative essentially says, do what you're doing, but try and see how you can scale it. So in that principle, I would say, if you are already using a threat modeling methodology, go ahead and continue that, because that would, if you change that, that essentially means you're completely rocking the boat. But if you've not yet used it, my personal recommendation would be to try and use the Stride because that kind of works well for us, and maybe it would for you as
well. I guess that answers it. Another question is, will SAST or DAST tools work in CI/CD pipeline?
Absolutely. I mean, that's the whole today. I mean, most of the DAST and SAST tools are designed today to work with CI/CD pipelines. You can just take any name brand SAST and DAST platform. I don't want to take any specific names here because I don't want to be favorable or biased towards anyone, but you take any commercial SaaS tool today and look up their website, and they will have a page, if not an entire document, that says that how well they connect with CI platforms like Jenkins or Bamboo or Travis. So most of the commercial platforms are designed today to work with the CI/CD pipeline because that's really the norm of the day. Open source platforms can also be made. Open source tools can also be made to work with CI/CD platforms. If anyone is interested, again, there is a very good write-up that we've written that gives you a very prescriptive way of integrating Burp and Zap with your CI/CD pipelines. It's a great read. It's very it's almost like a how-to. But the short answer is yes. All CI/CD, most SaaS and DaaS platforms will work with CI/CD pipelines.
So another question is, hey, our product releases get delayed due to too many false positives thrown out by SaaS platforms. How to address that?
Unfortunately, there is no tool that will eliminate false positives. It's really not there. It's one of those utopian dreams that would never be accomplished. However, what you can do is you can do two things. One is you can come to the false positive. If something can, so there are platforms like, we45 has a platform called Orchestron, and Orchestron essentially is a correlation platform, like I told you earlier on. So what correlation platforms essentially do is they have integrations to SAST and DAST tools, and then they would essentially get the results from these SAST and DAST tools, and then they would normalize it. When I say normalize it, they would essentially correlate results that are the same. And one of the things that they also do is they say certain vulnerabilities are potential false positives. So they might not actually say they are false positives, but they first say they are potential false positives. It essentially means that you can get to the false positives later on. You can first look at the true positives first, act on it, and then look at the second, and then look at the false positives later on. However, what's interesting is that Orchestron, at least I could speak for Orchestron because that's our product. One of the things that does is that you can also mark it as a false positive. The moment you know that something is a false positive, you can mark it the first time around, and after that, it would not show up again. But if you're looking to completely eliminate false positives, unfortunately, that's not something that at least we've seen. People are looking at various heuristic systems and algorithms to try and reduce it and eliminate it even, but there is no way to completely eliminate it at the tool level. But this is the best option that you have in terms of ensuring that the first time around, you see it separately, you validate it once, and then you can definitely ensure it doesn't come up again because you are very confident that it is a false positive.
Okay, another one is what would be a good place to start an SSI form? Security, automation, or training?
I would say training, because I think a security automation, if you see, we've talked about only in the third or the fourth phase, or the third phase of the SSI, right? Which is because they're essentially talking about automation. Automating always works well if you're trying to scale up something that you know for a fact works well in the first place. But however, if you're implementing SSI for the first time around, it always makes sense for us to have a good training program first that essentially normalize expectations across various stakeholders, and then look at automation. So automation might not be the might not be the first place to start an SSI. It would probably just create more chaos than what it did earlier.
We have one other. How do you include threat modeling in DevOps? Threat modeling is too difficult and too slow.
Yeah, this is one of the problems that we even spoke about during the webinar as well. Because of the way in which threat model is prescribed, if it's very, very prescriptive or more granular, it will definitely become a bottleneck. One of the ways that we have solved this problem, of course, if mature teams have a process already where they're saying that you have some kind of a threat modeling platform where, as part of the process, developers are supposed to feed in security requirements as part of the design principles, then that's great. Otherwise, the other way to do it is really look at threat models to be more as abuser cases, like what we kind of talked about. And people who are interested can look up this framework, the open source framework called the Threat Playbook. And Threat Playbook really it kind of helps you to start looking at threat model at an abuser case perspective itself. So you can start writing in very, very small threat models right from the get-go, and then help you kind of scale that. But for that apart, I think threat modeling is probably one of those things that will create that time barrier. It will kind of expand your engineering cycle by 10% or so, at least for the first time around, until it starts becoming the norm. It will kind of increase that time period, but then at the long run, I think once it becomes very seamless and part of the cycle, frameworks like Threat Playbook or even some commercial platforms that are out there could kind of help you really save up on a lot of time there.
Thanks again, Rahul. I think this, with this, our Q&A round comes to an end. Thank you guys for joining us. The recording of this webinar would be made available soon. And if you have any more questions, you can mail them to us at we45.com. Follow us on Twitter and sign up for our newsletter. we are conducting a formal DevSecOps training at ASSEC Day, Melbourne. You can register for the event, and for more details, visit our website. Thank you.
Thanks, everybody.